Hello. Today we're talking about parallel and perpendicular lines. So what we're going to do then are to understand the relationship between the slopes of two lines that are parallel to each other and do the same relationship between the slopes of perpendicular lines, and then also be able to find then those, if given a line, find the slopes of lines that are parallel to that line and then perpendicular to that line. So first, let's talk about parallel lines. So if you have two lines, say one line looks like this, then you have a parallel line. At least it looks like this, more or less. This is line number 2. Okay, these are parallel. And once again, what that means is that they have the same slope. So if you were able to calculate the slopes for both of them, you find the slopes are exactly the same. And also what that means, they never intersect, so they never cross each other. They never intersect each other. Okay, they're always moving either up or down at, or even could also be horizontally vertically parallel lines as well. That means they're always moving at the same rate, essentially. So think about also connected to the average rate of change, they have the same average rate of change. For example, we were talking about that. So those are parallel lines. So just remember, if you know the slope of one line, you know the slope of its parallel line. Now, then let's take a look down here at perpendicular lines. Let's say you have maybe even the same lines. This is line number 1. And then you have another line that crosses it like this, let's say. So this is a 90-degree angle. And this is line number 2. These are perpendicular lines. Let's abbreviate that. Perpendicular lines, they do cross a 90-degree angle, and that makes, of course, these what's or a right angle are called a 90-degree angle. These are perpendicular lines. Okay, so they cross. Of course, the lines can only cross, straight lines can only cross either once or be the same line. So in this case, then they have one intersection. If you measure this distance between the lines, any one of these angles is 90 degrees. Okay, so now let's practice a bit with finding parallel and perpendicular lines. Okay, so what we're going to do in these examples are find the equations, or find the slopes of parallel, let's abbreviate that, and perpendicular lines. 2, and I will give you in each case, we're going to give us a line, and want to find the slope that's parallel and perpendicular to that line. So number 1, let's say we have this line. So let's say this is written as y is equal to 2x plus 3. And we'll graph this line in a moment to make sure it actually is perpendicular. Okay. Now, of course, our slope, m, this line is 2. So for a parallel line, the slope is also the same. The slope is also 2. Okay. But then for perpendicular line, I have to do a bit more work. So perpendicular line, okay, the slope is what's called the negative reciprocal. Let's talk about how to find that. So for a perpendicular line, let's go below. So the slope is equal to, its negative reciprocal means what we're going to do is we're going to take the reciprocal of this, and reciprocal means we flip it. You think of this as being same as 2 or 2 over 1. So then it becomes reciprocal of that, then just negate it. Okay. And so that slope then is negative 1/2. Okay. So for any line that's parallel to this line, then its slope is 2. Any line with a slope of 2 is parallel to this line. Any line with a slope of 1/2 is perpendicular to this line. Let's go to Desmos and take a quick look at that. So double check line is yet. Original one is 2x plus 3 for Desmos, DESMOS.com. Let's graph the first line, y equals 2x plus 3. Okay, so there's our original line. Now let's do something down here. Let's do y equals 2x plus. What I'm going to do is put some in, it's a t. I can do this, right? You add slider. What this means then is that I can slide t back and forth, and we'll show that depending on what my t is my intercept for a line. So depending on where my t is, okay, that will change my y-intercept. And see, my slope is always the same. I'm always parallel to the original line, okay? These two lines never cross unless they're exactly the same line, okay? If they're exactly the same line, of course they cross, but other than that, they never cross, okay? That's what that means. So these two lines are always parallel to each other. Okay. Now, let's do the same thing with perpendicular to each other. So, well, I just, let's see. Y equals negative 1/2 x. So we'll just make the same line. It doesn't matter, we start anywhere. Plus, I'll do the same thing, plus t again. So use the same slider. Yeah, I can. Okay. So in the same way, here the t only changes the intercept. So no matter where my intercept is, as long as the slope of this line is negative reciprocal, negative 1/2, then my bluish colored line is always perpendicular. The slope of it is always, the angle between the two lines would always be 90 degrees, no matter what the intercept is. Okay, let's do one more example. And this time, let's do it a little bit differently. So go to number 2. Actually, let me think for just a moment. I'm sure I get what I want. Okay. Let's say this time this is going to be 4x plus 7y is equal to 1. Okay, now if you notice, this is a different form. This is called the standard form. So what we do here first to figure out what the slope is just to solve for y. Okay, now actually you can graph at Desmos like this. We may do that in a moment, but let's do this. So solve for y, so subtract 4x on both sides. And so first we have 7y is equal to negative 4x plus 1. Okay. Then divide both sides by 7. So I could show that. So we subtracted 4x on both sides. And those cancel out. 7's here will cancel out. And we have, I'm going to break this up, split this up in 2. You can do that with a fraction. So this will become negative 4/7 x plus 1/7. Okay, so that's our line. Now, so our slope, m, of course, is a number in front of the x, negative 4/7. So once again, so for a parallel line, the slope would be the same, negative 4/7. Okay, then for a perpendicular line, this would be the negative reciprocal. So there, the slope. So once again, we flip it. Okay, so flip this, becomes negative 7/4, and then negate it, negative reciprocal. So it's reciprocal, which is negative 7/4, then negate that, and that's going to be 7/4. Okay, so this is any line that's parallel to the original one will have this slope. Any line that's perpendicular to the original will have this slope. And also one thing to keep in mind as well, most lines you come across are not going to be parallel or perpendicular. They're going to be, most of the cases, they're going to be neither. But this is something useful to understand. Let's go back and take a look at this one. And actually, let's jot a couple things down. So negative. Okay. Let's go back and take a look at Desmos. Actually, I think I'm just going to delete all of these. Now, as I mentioned, we can actually graph, those ones will graph that line in the standard form. Let's do 4x plus 7y is equal to 1. Okay, so that's our line. Now, let's show this is true. So now let's do y is equal to negative 4/7 x plus 1/7. Now if we do that, plus 1/7, so we get the same line, okay? Now this time, let's make this like we did. Let's make this t, add a slider, do the same thing. So as long as my slope is the same, I'm just changing my y-intercept. As long as my slope is the same, the line I create is always parallel to the original. As long as it's the same slope, those two lines will never intersect unless they're actually the same line, okay? Now, let's come down here. Let's actually get rid of this one. Let's do this time the perpendicular one, y equals 7/4. That was our perpendicular slope plus t. Okay, and as you can see, in the same way, if I move my t, all I'm doing is changing my intercept. And so as long as the slope is 7/4, the line I create is always perpendicular to the original line. Okay, so we've learned today then just the basics of parallel and perpendicular slopes. Remember that most lines in life are neither parallel or perpendicular to each other, but it is useful to understand that. So what we've learned is that what it means for lines to be parallel and perpendicular, how to find the slopes of lines that are parallel and perpendicular to a given line. Thank you. Have a good day.